Hi, this is Miss Park. This video is going to lead us into trigonometry word problems. One of the things that is common with trig word problems when we have right angle triangles is the concept of angle of elevation and angle of depression. So if you are standing on the ground and looking up, the angle with which you are looking up is called the angle of elevation. Angle of elevation. It is measured from the horizontal. So the horizontal is if you were to look straight across. So from the horizontal, measured to where you're looking up, that is called the angle of elevation. So if they tell you that that you're standing somewhere and you're looking up at something, then that's going to be an angle of elevation. The other one is called angle of depression. An angle of depression is when you're standing at the top looking down, so like this bird, okay? The horizontal for this bird would look like this, but if this bird is looking down at this girl, then the angle of depression is measured in here. This is angle of depression. So both angle of elevation and angle of depression are measured between the horizontal and where the person is looking, or called the sight line. Measured between the horizontal and the sight line. Measured between the horizontal and the sight line. Okay, so those are those two concepts. Now you'll notice something. If you remember the parallel lines that you learned in grade 8 and 9, this horizontal here and this horizontal here are actually parallel. So if they're going to be parallel, there's patterns that are made with the angles in between. So you may recall something called the Zed pattern. The math word for it is that they said alternating angles. Alternating angles are the ones inside the Z. So in a Z pattern where you have these two lines parallel, alternating angles are equal. So notice if they said that the bird is looking down with an angle of depression of 30 degrees, then this is 30 degrees. And since this is drawn outside the triangle, it's actually, using the Z pattern, the same as this one in here. So you could put 30 degrees here. Right? So if we want to label the triangle, we need angles inside the triangle so we can use trig. So if they tell you there's an angle of depression of 30 degrees, well, you know from the Z pattern that there's also 30 degrees here. And that's how to use that angle inside the triangle. Right, this is a page in your booklet. Let's look at a couple of word problems that were assigned. Okay, so I'm on page 21 in the textbook. Okay, the first one gives you a diagram. So anytime it gives you a diagram, you're okay, you can figure it out. But sometimes you don't get a diagram, and those are the harder problems. So this one says, from the top of a bridge over the Burlington Canal, Maria looks down at a sailboat at an angle of depression of 15 degrees. The bridge is 18 meters above the water. Calculate the horizontal distance from the bridge to the sailboat. Okay, so she is standing at the top of a bridge here that it's telling us is 18 meters above the water. So here's 18 meters. Here's the water. Okay, there's a sailboat in the water. All right, and she's standing up here and she's looking down at the sailboat. Okay, and now it's telling us that she's looking down with an angle of depression of 15 degrees. So here she is. Here's her eye, and she's going to be looking down at the sailboat. So the angle between her horizontal, looking straight across, and looking down is 15 degrees. And now the question says, calculate the horizontal distance from the bridge to the sailboat. So horizontal distance is from here to here. So this is our x. All right, so here we have our diagram. Now this 15 degrees is sitting outside the triangle. Well, we can use the Z to bring it inside. All right, and so now really what I have is I have a triangle that looks like this. The bridge is perpendicular to the ground or to the water, so that's 90 degrees. This is 15 and this is 8. And now if I want, this looks like any old right angle triangle that we've already been working with. From the 15 degrees, I can label the sides. This is hypotenuse. Across from the 15 degrees is 18, which is the opposite. And this one here is the adjacent. And they're asking us for the adjacent. So what is involved in the question? Just the opposite and the adjacent. Hypotenuse is not involved because they didn't ask for it and they didn't give it. So now we solve the problem. I'm going to write SOH CAH TOA and decide which one I'll use. I see I have opposite and adjacent, so I use that, tan, and I will write this. So tan of 15 degrees equals opposite over adjacent. That's from SOH CAH TOA. The tan of 15 degrees equals 18 over x. Now I want to solve for x, so we'll put this over 1. Cross multiply. X times tan 15 equals 1 times 18. And so x tan 15 is 18. But tan 15 is just a number from the calculator, so x times that number. To get x alone, we just divide by that number on both sides. And so x, these two will cancel out, and so x is just equal to 18 divided by tan 15. And so I'm just going to grab my calculator in degree mode and go 18 divided by tan 15, and I get 67.2 approximately. So x is approximately 67.2. Okay, and then I write my therefore statement, my concluding statement. Therefore, the boat is approximately 67.2 meters from the bridge. And that's it. Okay, so that's your angle of elevation, angle of depression. All right, do your practice, please. Lots of word problems in the textbook. Thanks for watching.